Hey everybody, this is going to be the notes for lesson 1, cubes and getting the function from the zeros for the week of March 30th. One of the things that you need to have when we're working with the cubes and factoring is you need to know the cubes. If you don't have your power card, here are the cubes. Why don't you pause the video and get them down. So we're going to first talk about the formula for the sum of cubes. And here's the formula for that. And you might pause again and get that written down. Now we're going to do our example for the sum of cubes. The first thing we're going to do is identify what A is going to be and what B is going to be. You ask yourself, what did you cube to get 343y cubed, which was 7y? Then you ask to get your B, you look at the second term in the polynomial and ask yourself, what did you cube to get 1000z to the third? And that's 10z. Then we're going to use the formula. It's formula, the first factor, the short factor is a plus b. So ours is going to be 7y plus 10z. Then we're going to have our long factor, which our formula has a squared, which is 7y squared, which is 49y squared, minus, and notice that's the opposite sign of the first sign, is going to be a times b, so then that's going to be 7y times 10z, which is 70yz. And then the last term is always positive, so then that's going to be plus 10z squared, which is 100z squared. And then that's our answer. Okay? Make sure you get this formula, okay, for the sum of cubes. Now we're going to have our second formula, which is the formula for the difference of cubes to factor it. Okay, and here's the formula. You might pause it and get that formula written down. And here we're going to go through an example. The first thing we're going to do is get A and B. A is in the first term of the polynomial, and you need to ask yourself, what did you cube to get 125k to the third, which is 5k. Then to get the second, or the second term, to get the B, you ask yourself, what did you take to the third power to get 512n to the third, which would be 8n. So now we have our A and B, so then we're going to use our formula. So there it is, there's the formula. So the first factor, the short factor, is A minus B, so it's 5k minus 8n. Then we have our long factor, which is going to be A squared, so we're going to have 5k squared, which is 25k squared. And then the next sign is going to be opposite of the first, so it's going to be a plus. And then it's going to be A times B, so 5k times 8n, which is 40kn. The last term is always positive, so plus b squared, and so we're going to have 8n squared, which would be 64n squared. So our answer is the short factor, 5k minus 8n, times our long factor of 25k squared plus 40kn plus 64n squared. You cannot get this written down. You might pause it and get everything written down. The other thing that we're going to talk about, and we've talked about zeros of graphs. In fact, we're going to use those to find the polynomial function. It's not that difficult. Here are the steps. And you might pause it. If you need to write those down, you can. The steps finding the polynomial function given the graph. Okay, you're going to find the zeros or the x-intercepts. The one thing we're going to do is we're going to set them equal to 0. If there's any fractions, we're going to get rid of them, okay, by multiplying by the denominator. We're going to make each equation equal to 0. And then our factors of the polynomial is the stuff on the side opposite of the 0. And if the graph has an x-intercept sitting on the x-axis or hanging from the x-axis, the factor is squared. And we put parentheses around the factors, and we can multiply. This time we're not going to, but I'll show you that. Here's our first example. Here's our graph right here. And I want you to notice that our zeros are at -2, 1, and 2. And so I came over here and I wrote down what my zeros are. But here's the graph, and you might pause it so that you can see where they're at. But here are the zeros. The thing I'm going to do is I'm going to set each of those equal to x. X equals, x equals, x equals. The next thing I'm going to do is I'm going to make the equations equal to 0. So I'm going to subtract 2 here. And I'm going to get x minus 2 equals 0. Underline the x minus 2. On the second equation, I'm going to subtract 1 on both sides. Oh, that should be a -2 right there. Let's make that +2, +2, +2. Correct it. Got it. It's x plus 2. Then our second 0, it was 1, and we're going to subtract 1. So we're going to have x minus 1 equals 0. And so our second factor is going to be x minus 1. And then on the next factor, I'm going to subtract 2. So I get x minus 2 equals 0. Put a line underneath the x minus 2. What I have underlined, those are the factors for our function. So we're going to write f of x equals x plus 2 times x minus 1 times x minus 2. And there's our function. And that's our answer. Okay? So we have always done the zeros and listed them out. Okay? We know those are the x-intercepts. But what we're going to do different is get the factor. Okay? So getting the factor, we're going to set each of these equations equal to 0 and solve for x. Okay? And so that's our first example. Then we're going to look at our second example. And here is our graph right here. And my zeros are at 1.5 and 4. So that's the first thing I'm going to write down. Zeros are at 1.5 and 4. I am going to go ahead and put zeros, 1.5 and 4. I'm going to set each of those equal to x. So x equals. And then I'm going to solve for x. I'm going to have them equal to 0. So I'm going to go ahead and subtract 1.5 on both sides. And I get x minus 1.5 equals 0. And over here, I'm going to subtract 4, and I'm going to get x minus 4 equals 0. Underline the x minus 1.5 and x minus 4. Those are my two factors. However, where x equals 4, if it's sitting or hanging from the x-axis, and it is right here, that means I'm going to have a quantity squared on that factor. So when I do my function for f of x, it is going to be x minus